That bonfire you are picturing right now, the campfire, the match flame, the candle on your birthday cake, the wildfire consuming a forest. All of it, fire, is a chemical reaction. Electrons rearranging, molecules breaking apart. A process so slow, so weak, so fundamentally ordinary that comparing it to the sun is like comparing a tap dripping to every ocean on Earth moving at once. The sun is not on fire. It has never been on fire. And the thing it actually is makes fire look like a rounding error.
In this video, we are going to do three things. First, we are going to explain exactly why fire and the sun are not even in the same category of phenomenon. Not just different in size, different in kind. Second, we are going to walk through a series of comparisons that will make every fire you have ever seen feel almost comically small. And third, we are going to get to the part that nobody talks about. What the sun is actually doing to itself right now, every second, and what that means for us and for every living thing on this planet. By the end of this video, you will look at the sunrise tomorrow morning differently. Not poetically differently, physically differently. Because you will know what you are actually looking at. Let us be precise about what fire actually is. Fire is a rapid oxidation reaction. A fuel, wood, gas, wax, reacts with oxygen in the air. Chemical bonds break. New chemical bonds form. Energy is released in the process as heat and light. The light we see as a flame is photons being emitted by excited molecules. Hot gases glowing as they release energy. The maximum temperature of a wood fire is around 1100 degrees Celsius. A blowtorch reaches about 1600 degrees Celsius. The hottest fire achievable with conventional chemistry, cyanogen burning in pure oxygen, reaches about 4500 degrees Celsius. This is the ceiling of fire, the best that chemical combustion can ever do. The surface of the sun, its coolest, outermost visible layer, is approximately 5500 degrees Celsius. So the surface of the sun is already hotter than the absolute maximum temperature of fire. But that is not even close to where the story ends. Because the surface of the sun is not where the energy comes from. The surface is just the exhaust. The place where energy finally escapes after a 100,000-year journey outward from the core. At the core of the sun, the temperature is approximately 15 million degrees Celsius. The hottest fire you can build, 4,500 degrees. The center of the sun, 15 million degrees. But temperature is still not the most important difference. The most important difference is the process itself. The sun is not burning. The sun is fusing. At its core, hydrogen atoms are being crushed together with such extreme force, such extreme temperature and pressure, that they overcome the electromagnetic repulsion that normally keeps atomic nuclei apart and merge into helium. This process is called nuclear fusion. And what makes it categorically different from fire is not just the temperature, it is the source of the energy. In fire, energy comes from electrons rearranging between atoms. The atoms themselves are unchanged. Only the bonds between them shift. In nuclear fusion, the atoms themselves are changed. matter is converted directly into energy. Einstein's equation, E equals mc squared. Energy equals mass multiplied by the speed of light squared. The speed of light is 300 million meters per second. Squared, that is approximately 90 quadrillion. Which means that even a tiny amount of mass, when converted directly into energy, releases an incomprehensible amount of power. Every second, the sun converts approximately 600 million tons of hydrogen into helium. In that conversion, about 4 million tons of matter is transformed directly into pure energy. 4 million tons, every second, gone, turned into light and heat. To put that in terms that connect to something you have experienced, the largest nuclear bomb ever detonated, the Tsar Bomba, converted approximately 2.8 kilograms of matter into energy. 2.8 kilograms, the weight of a bag of sugar. That explosion was the most powerful human event in recorded history. The sun does the equivalent of roughly 700 billion Tsar Bombas every single second. And yet, when we picture the sun, we call it a giant ball of fire. In movies, in textbooks, in casual conversation. A fireball. Burning. Blazing. Now that you know what it actually is, let us walk through exactly how embarrassingly small fire looks by comparison. Not in abstract numbers, in images you can actually feel. Comparison 1. Size. The largest wildfire in recorded history, the Black Summer fires in Australia in 2019 and 2020, burned approximately 24 million hectares, an area larger than the entire United Kingdom. The largest fire in human memory. Catastrophic, devastating, historically unprecedented. The surface area of the sun is approximately 12,000 times the total surface area of the Earth. Every square meter of the sun's surface emits more energy every second than the total electrical output of the entire city of Mumbai for an entire year. Not the whole country, not for a decade. 1 square meter, 1 second, one city's annual electricity. Comparison 2. Energy output. Humanity's total energy consumption in 2023, every car, every factory, every device on Earth combined, was approximately 600 exajoules. The sun outputs approximately 380 yotajoules of energy per second. 1 yotajoule is 10 to the power of 24 joules. The sun produces in 1 second what all human civilization uses in roughly 800,000 years. Comparison 3. Duration. A match flame lasts a few seconds. A candle, a few hours. A bonfire, a few days. The largest volcanic eruptions in history, enormous geothermal events, last months to years. The sun has been fusing hydrogen for approximately 4.6 billion years. And it has enough hydrogen remaining to continue for another 5 billion years. Total lifespan, approximately 10 billion years. For context, every human civilization that has ever existed fits into a span of roughly 10,000 years. The sun's operational lifespan is 1 million times longer. Comparison 4. Efficiency. A typical fire converts roughly 20 to 40% of its fuel into useful energy. Most of the rest is lost as turbulence, incomplete combustion, smoke. Nuclear fusion in the Sun converts mass to energy at an efficiency of approximately 0.7%. That sounds lower, but consider what is being converted. Not chemical bonds, mass itself. At E equals mc squared, 0.7% of mass converted to energy per gram of hydrogen fused releases more energy than burning 20 million grams of coal. 1 gram of hydrogen fuel equivalent to 20 tons of coal.
Remember the bonfire from the beginning of this video? The one that looked impressive in close-up. The warmth, the crackling, the glow in the dark. Nothing about a bonfire has changed. It is still warm, still beautiful, still genuinely useful for cooking and warmth. But you now know what it is. Electrons shuffling between molecules. A chemical reaction so slow and so low energy that the Sun does its equivalent 700 billion times over every second without noticing. But here is where the story takes a turn. Because understanding what the Sun actually is raises a question that is much harder to sit with. What happens when it stops? The Sun is 4.6 billion years old. It is roughly halfway through its hydrogen fuel supply. In approximately 5 billion years, it will exhaust the hydrogen in its core. When this happens, the core will contract under its own gravity. The outer layers of the Sun will expand dramatically. The Sun will become what is called a red giant. Its outer atmosphere will swell outward to perhaps 200 times its current radius. Far enough to engulf Mercury, far enough to engulf Venus. And depending on how much mass the Sun loses as it expands, possibly far enough to engulf the Earth itself. Even if Earth escapes direct engulfment, the increased luminosity of the red giant Sun will have already boiled Earth's oceans completely dry, approximately 1 billion years before that final expansion. 1 billion years from now, the oceans gone, the surface sterilized, the end of the biosphere. And yet, that same process, that same expansion, that same death will see the interstellar medium with the atoms that were forged in the Sun's core. Carbon, oxygen, silicon, nitrogen. The atoms of biology. Scattered outward in a planetary nebula, waiting to be incorporated into a new solar system. New planets, potentially new life. The Sun does not end, it transforms, and the atoms it releases become the raw material of futures we cannot imagine. You are, right now, made of atoms forged in a star that died billions of years before the Sun was born. When the Sun dies, its atoms will become something else. The universe does not waste material. It recycles at the nuclear level. Tomorrow morning, when the Sun rises, here is what you will actually be watching. A thermonuclear reactor 1.4 million kilometers wide, converting 4 million tons of matter into pure energy every second. Having done this without interruption for 4.6 billion years. Its surface, a churning plasma ocean at 5,500 degrees Celsius. Its core at 15 million degrees,
where protons fuse and matter ceases to exist as matter. Its light, right now crossing your retina, left the sun 8 minutes and 20 seconds ago. It was produced by a fusion event that began 100,000 years ago in the core and spent that entire time fighting its way to the surface. That is the sunrise. Not a ball of fire. A nuclear engine so powerful it makes every fire ever lit on Earth, every candle, every furnace, every explosion, look like something you could extinguish with a breath.
And it has been doing this your entire life. Every life that has ever been lived. Every civilization that ever existed. Every second of every day. Without asking for anything in return. Microspace makes videos like this one because the real universe is so much stranger and so much more extraordinary than the simplified version most of us were taught. Next time, we are looking at another thing you think you understand. Water. You have been drinking it your entire life, and it behaves in ways that should be physically impossible. Subscribe to find out why.